attending. Today's webinar is based on Inventor 2019, defining tolerances, Inventor 2019. It's enhancements to the Inventor model-based definition and tolerancing. We've done a class previously as an introduction to it. This is also based on the model-based definition and tolerancing inside of Inventor 2019, but we'll also look at the previous recap on the previous class that we've done. So just a quick introduction to the class, the agenda of it. So it's introduction. We'll look at the Industry 4.0 and where does model-based definition tolerancing fits in. Next is what is the model-based definition and how do you design with it, as well as the functionalities, some enhancements to Inventor 2019, and then also design to manufacture and how is it being used out in industry. We'll look at some of the key takeaways and then obviously the questions and answers that follow at end. So just to start, some of the learning outcomes. So Industry 4.0 is changing the design environment. So how we design is different. The way we manufacture is different. And of course, with the next industrial revolution, which is the Industry 4.0 as it's more commonly known, we find that there's a lot of automation going on, and automation from the Internet of Things, machine learning, and there's many different factors that play a part into this. New drawing standards. So the standards are changing in the sense that the way we do drawings, the way we do design is changing. Annotation automation. So we'll automate some of our annotations that we're going to add into drawings for models and see how that works in an example. And also from design to manufacture. And that's also changing quite rapidly in the sense that if we look at the way we design, traditionally we would take it into CNC, still maintaining the same workflow, but the added advantages with model-based definition tolerancing. So let's start off. We're looking at the Industry 4.0. So as you can see, it's a factory of the future, Industry 4.0, and smarter factories. So it gives us the ability to be more intuitive in how we design, and where does and how we machine, and how does the machines operate and how the machines work. Now, where does model-based definition tolerancing fit inside of this? So what does this really mean? So in Industry 4.0, you see the current trend of automation, okay, as we discussed, is changing the data exchange inside of manufacturing technology. It creates smarter factories, smarter way of production, smarter ways of actually working, and also smarter ways of designing. And the important pillars here is the intelligent production, right? So intelligent production of how we produce our products and how we work with them. So all this information that we had, this can be used downstream, and there's certain areas that you can see it being worked in here. Now you can see it from a documentation point of view, from a 3D PDF point of view. So how do you share your 3D PDFs with other users and or colleagues that need to actually look at it, and what information you add into it? Because again, going back to the Industry 4.0 or the smarter ways of designing, smarter factories, smarter products, information and data is critical and key to each stage of it. Also looking at tolerance analysis, advisors on tolerance. How do we advise? How do we know the analysis of the tolerance that we're working with and how we're doing that and how we're producing these designs for manufacturing? Again, also keeping in certain formats and also certain regulations. We also look at how is that data used downstream for the NC coding or NC side of it for our machining. And the approach to model-based definition is a bit different, right? Autodesk views it to be more tightly integrated with the robust design, and also capabilities from very beginning to maximize the powers of incorporating manufacturing information directly into the 3D model. And what this allows is the downstream use of the information added in. So again, going back to model-based definition, what is it? So we've touched on this previously, but just to recap, model-based definition refers to a fully defined 3D model of individual components and product assemblies. The types of information that you could add into it include, of course, the metadata, which is the eye properties, tolerancing dimensions, the GD&T, okay, surface finishing, the hole and thread, and also general notes. So what it comprises of is very similar to what we normally do in a drawing environment. However, in this scenario, we see that it's actually more equipped for using it in the 3D model itself, and that data is used downstream. Now going into some of the standards here. So the title caption here is going back to school. So basically, the way we learn these standards, the way we use these new rules, so there's new standards and new rules, we cannot apply 2D annotations to this 3D environment rules, right? And we'll see why as well as we move along, okay? The two types of deliveries that we can find here is the model only delivery and the model and drawing. Now, what's nice about this, if we look at the model deliveries, we find that product definition data, okay, including but not limited to, of course, notes and dimension and something shall be added in to the model environment, and that, which brings us to the next point, allows us to use it downstream in the design process. So what does this mean and how does it work for us, right? So when we work with a model which has complete definition of a product, right, and notes and indicating views, or it could have been any whole information or any information that's related to the model itself, we can always call this up in the drawing environment. So we're basically using the information inputted in the model downstream into the drawing environment, allowing us to save time, but also keeping metadata as we move along. So what it looks like, okay, so if we look at working according to a new standard, we see that in the model on the right hand side, on the left hand side is what we have input inside of the model, and the information in there is carried across on the right hand side, which is the drawing environment. And of course, as we do sections or as we place down views, our notes will come in and our information that we add in. So the requirements that we look at in the drawing requirements, features can be shown in the actual position with foreshortening or alignment, right? When the section is made in the view, okay? And as you can see in the image here, how it projects and how it looks. If you're doing fillets, it comes in, okay, fillet all rounds, and also fillet with equal offsets, that also comes in. So we have the ability to actually bring in all of these notes. Also, if we look at it from a placement of annotation, so the straightness is defined by the annotation plane. So based on the plane that we work with, the plane and placement and attachment bases on that, okay. And also dimensioning a slot, for instance, you see that the information that comes in and where the positioning of the holes are going to be. So that's all based in the model. How do we take it into the drawing environment? With Inventor, you can see that you can retrieve the model annotations, and as you bring it into the drawing sheet, you will find that it doesn't come in automatically. However, when you go in to retrieve the model annotations, you see it comes in looking something similar to this. So on the left-hand side, you will see a snapshot of the model itself, and on the right, you would find that this is how it looks when it comes into the drawing environment. So let's talk about exporting these model information and what formats you can export them in. Now, firstly, the CAD formats that we know directly out of Inventor, and it's listed here. You could export it in multiple formats, as shown. If you need to generate a step file of it, so step 242, and you can see there as you save it, the application option of it, or the save option, will allow you to actually choose the model-based 3D engineering information to come in. What about 3D PDFs? You could also export this out as a 3D PDF with all of the information that will come into it. Okay, that's for our normal standard CAD models. If we look at the sheet metal side of it, only 3D model is exported, okay, and annotation and a flat pattern are not exported. So that's something to take in consideration. When you're exporting out in the flat pattern, that does not come in. If we move on to some of the functionality of how it works, we would find that there's a couple of environments that's supported here. Okay, so the environments that we look at is the part environment, the sheet metal environment, folded and unfolded. Okay, so although you cannot export it out as unfolded with the information coming in, but when it is folded inside of the drawing, inside of the model, sorry, you would find that that information is still in there. Okay, and then also context part edit that also comes in, right? So that's the environment that is supported inside of Inventor. If we look at the standards, we can see that it's ASME Y14.14 2003, also the DIN ISO standard that's in there, as well as the ISO standard that also comes in. So these are standards that you can choose of, or style definitions. Talking about style definitions, when we select our definitions to change the style or the environment that we're working with, we can see that the annotation style in the definition settings, you can go in and change it. So the active style in this example was ISO, but the drop-down screen on the right-hand side, you can actually see there's the different standards that you can pick up. All right, you can change the style in the drawing environment as well. Also, you can you can prompt for set previous files to start when you're doing the annotations as well. So you can actually have this set up to the way you work and the standard that you work in. If you look at the style management of it, okay, in here, you can go into the style settings, okay, and you can actually go and change the standards that you can work in, and make sure it you can create a substandard from scratch as well. So you can modify these styles to your work environment, the way you want to actually work with it. If we look at some of the functionality, so you'll find this is the Inventor. On the Inventor ribbon, you'll find the features that you can work with. So the really nice thing is the tolerance advisor, which gives you kind of health checks of the model itself, okay, based on the tolerance scheme itself. Geometric annotations, as you can see there, includes the GD&T. It also includes standard-based validation and advice. That's using the tolerance advisor. Automatic recognition of tolerance features that comes in, you can have this switched on, as well as the downstream consumption, okay? And this is all powered by using Inventor. You're working with it directly from Inventor itself. If you look at the general annotation and the note side of it, this is very similar to how you would add in your notes. So you've got functions and tools like dimensions, throw a hole and thread notes, surface textures that you can use, as well as the general notes tab that you could work with inside of in the drawing environment. So that what you would do is you would add it into the model environment and use that downstream. On the far right, you'll find that the consumption of this can be used downstream. Again, you could export this out as a 3D PDF, or alternatively export it out as a different CAD format, which is great. So I think we might have had a slight technical issue there. For the guys that didn't catch up, please let me know if there has been an issue. At the moment, we are on the page that discusses the model-based functionality that you find inside of Inventor itself. All right. So moving along to that, we find that we've got the feature tree that also includes this functionality. So if you go into the feature tree under annotations, you'll be able to see the dimensions or the annotations that you're adding into it. Now, what is great here is that it forms part of the design, as you can see on the image on the right, and whatever information that's being added in will come in to the design itself, as shown in the image. Now, annotations folder is there. You've got a tolerance feature folder there, which is also available. So if you expand that folder, you'll be able to see the tolerancing that's being inserted inside of the design, as well as the annotations that's going into it. Now, you can control the visibility of it, very similar to the way you would control the visibility of working in the normal 3D CAD environment, where you could switch the visibility on or off. So let's have a look at the tolerance placement and the orientations. So how would you place it? How would you orientate this? In here, you would go in and use the space bar, okay, to toggle between the next candidate plane. So by clicking on spacebar allows you to toggle the geometry. The tabs allow you to toggle the alignment, and of course using shift for selecting an annotation plane. So it's basically 3 key commands that you would work with when you're using it, and it'll allow you to actually toggle, align, and select annotation plane for when you're doing the placement of the tolerancing features. Now, if we move on to that, we find that in the design view, you could actually lock your view, okay? If you lock the view, new annotation is automatically hidden, right? If you change your camera view to save current camera, you can do your changes in your template. And as you can see there, by just right-clicking on the view, you could actually go in and change that in there. When you're publishing it, the view will automatically be marked for publish for 3D PDF, okay? Before creating, you can adjust this manually, of course, and also the annotation scale, you could set that up manually. Also will be a default. If you need to set up the scale, you can go in and change it based on the settings on the right. Let's have a look at the next example, which will give us slightly bit more information in what we actually discussed.
More and more manufacturers are implementing the use of rapid prototyping and CNC into their workflows. And as a result, communication of design intent and specifications through your 3D model is more critical than ever. New model-based definition tools in Autodesk Inventor 2018 allow you to add geometric dimensioning and tolerancing annotation, or GD&T, and other manufacturing information directly to your 3D model, meaning that you no longer need to wait until both the 3D model and the 2D documentation is complete before beginning the process of prototyping or even manufacturing your designs. Instead, annotations are added to the model to describe the tolerances, controls, and allowable variations in the model, resulting in a fully defined 3D model. To reduce errors, Inventor 2018 adds a tolerance advisor tool within the 3D modeling environment to help identify and resolve common problems related to your tolerancing scheme. The visibility and scale of 3D annotation can be set through design views, giving users control over how and when 3D annotation is displayed. Once 3D annotation has been added and verified, the model can then be exported to a 3D PDF for enhanced collaboration. All annotation is visible in the 3D PDF, and when the annotation is selected, you can see what surfaces are included. Annotation data can also be exported to a STEP AP242 file. This industry standard protocol used during export allows this information to be utilized downstream in other manufacturing processes. This gives manufacturers a more complete three-dimensional model. And when you're ready to document your model in two-dimensional drawings, model-based definition annotation can easily be retrieved and placed onto your 2D drawing views without the need to recreate them. Model-based definition tools in Autodesk Inventor 2018 streamline communication between engineering and manufacturing by directly integrating design intent into your 3D models.
Okay, just an overview of what you can do and how you can export it, and I think it's really, really nice feature if you haven't been using it or working on it. So let's look at some of the enhancements made to Inventor and the model-based definition and tolerancing in 2019.
Model-based definition tools in Autodesk Inventor allow you to dimension, annotate, and tolerance your 3D models. The Tolerance Advisor built into Inventor now allows you to display the constraint state of all surfaces. You can now quickly identify right on the model what surfaces are fully or partially constrained, unconstrained, and even surfaces that are constrained by a general surface profile. This enhancement, along with existing MBD tools, help ensure your 3D models meet manufacturing specifications for downstream consumption. The hole and thread node now automatically display pattern quantities similar to the tolerance feature. Model-based definition tools in Autodesk Inventor 2019 help you quickly and accurately document your 3D designs.
Okay, that's actually quite nice. If we look at it, if we look at the from Inventor 2018.1 enhancements, we find that the new tolerance feature was introduced, okay, with nice new tolerance annotations that came in with it, 3D annotation for assemblies, and also didn't have geometric tolerances on it, all right, in 2018.1. And you can see that it had the free state, the projected tolerance zone, and also the statistical tolerance that you could use, but also the tangent plane was also available to you in 2018.1. Now, if we look at the model-based definition tolerancing in 2018.2, the enhancement to that, we found that control size and form of a feature. In addition to these controls, the location or orientation when the datum reference frame is used, it could also be available to you. You had the DWF export. I'm not sure if a lot of you use the DWF for exports and for working with it. And of course, you had the 3D PDF export with associated faces that highlight tolerances and annotations for multiple faces that you could use. If we look at it moving forward in 2019, we see that the model-based definition and tolerancing tolerance face advisor status is available. So there is some added features to this and some really nice ones. And the first one, you can see that with the tolerance advisor face status, which gives you different colors. And you can actually see that by selecting the faces of them, okay? The 3D annotation hole and thread quantity that was added into it. So if you used it before, you'd find this to be a really nice feature. And also the need to set up or change the style and add quantity is also available to you. Let's have a look at this in a bit more detail. So inside of Inventor, we go into it, open up a part. And then this looks at the faces, okay, the colored faces that we're going to work off. We pull up the model and we go into our annotations tab, and we can on the ribbon we can see this, and then we just pull in some dimensions of it. And we can see here with the faces of it, you've got the planar surfaces that you can pull out, and you can choose the type and how you want to add that in. But also you've got the advisor at the bottom that tells you the different constraints of it. So if it's fully constrained, if it's partially constrained or unconstrained, and based on the color scheme that you see there, you'd be able to actually see that and make sense of what it is. Now, adding more dimension to this, you can edit the tolerance that's in here. You've got the tolerance advisor opened up on the browser tree on the left-hand side. You could actually go in and see what's going on there. We carry on adding some planar faces and adding some tolerances to that. And this can be editable as well as we're working. So it can be, allows us to modify and change it as we go along with it. Now, if we look at the datum that's there, we can go in and just escape that. Okay, we could change the information that's been inputted on there. And as you can see that, the change in the constraint, okay? So it's partially constrained. So the first two faces, so the first two edges that we worked with, are fully constrained. The second is partially. As we change it, you see that it goes back to being fully constrained. Now, the general notes, we can add that in here. When we drop in our notes tab, we can go in and we can add in any manufacturing information in manufacturing notes to be added into the model. Now, let's have a look on the left-hand side here at our tolerance advisor, and we can see that there is some warnings that come in. It tells you it's not referenced. So we'll have to go in and, of course, reference that to get rid of that advisor warning. Okay, and we can select the reference, double-clicking on that, and the first one's gone. And if we need to go back, we can go back and change it. Okay, let's pause that. Okay. All right, so you can see, as you can see, it allows us to actually work with a really nice feature which tells us what's constrained, what's partially constrained, what's fully constrained. Okay, sorry. The best practices here. So you've heard something called PMI, so product manufacturing information, product manufacturing information in assemblies. And in here, the best practice is obviously to actually go in and put as much information that we need to work with. What about looking at a DWF workflow? So I'm not sure if anyone has used this function or feature. Let's have a look at it. So we can export this out into DWF. Okay, we can publish that. Okay, we name it, and it's the same model we worked with. We open up the design reviewer to actually view it, and our information that we added in, including our notes, come in across as well. We can change the orientation of it, and in here, we can set up views that we can work with, so our published views. Let's have a look at this from top, okay? And we can just make sure that the views are on, so we can switch it off. Let's switch it back on so we can work with it. And in this environment, you can see that you can start creating new views or saving views in here as well to what we're working with. Rename it to the machine. Okay, we'll just give it an ABC name. So this is the machining that's coming out of it. And there's the annotation that we can select, which is great because this can be shared across, again, downstream as just a viewing file. And if we click on that, we can actually go in and hide a few views. So if we don't want to give all of the information in our viewing file, we can actually just share a couple of them. Now, this is important for the guys that do not have CAD or do not have access to specific CAD programs or 3D modeling programs that need to actually review this design that you're working on. Again, we can go in and rename and save a different view out here. So we'll call this machine XYZ. So it gives us the coordinates, how we're going to work with it. And you will see later on, this becomes, on the next bit, that it becomes quite interesting to actually work off, in a sense that when we do this downstream, how that information comes in. So talking about you working with it downstream, let's look at design to manufacture and how we would use design to manufacture. Now in here, there's quite a bit of information because what this allows us to do, the 3D annotations are visible while programming machine code, okay, for HSM. So you can use this in introduction with HSM, but you can also use it with the other Autodesk CAM products like the Power Mill and Power Inspect and Power Shape and also FeatureCam. But let's talk about the ones in HSM first. This gives you more insight into the required precision that you're working with. Also, milling and clamping strategies can be adopted in here based on obviously the sizes that you're going to work off, and also the tolerance settings inside of Inventor. Post-processing of model for the production, you could reference this back to see what the post processes are going to, or how to post processes to the machine. And what's important in here is the inside of having the parameters to see the sizing of the components as it's being moved across. Let's have a look at something more on the FeatureCam side of it. So FeatureCam, another application or other CAM tool used by an Autodesk CAM product. And let's have a look and see how model-based definition processing is worked in here.
When you receive a part designed to be machined, you need to know the design intent in order to produce a component that passes inspection. Designers will therefore add product manufacturing information, which includes the geometric dimensioning and tolerancing, or GD&T, to help you manufacture a quality product. Autodesk FeatureCam provides the capability to import a variety of CAD data formats that contain product manufacturing information, either natively or through the Autodesk Manufacturing Data Exchange utility, to help improve design communication. Once imported, the product manufacturing information is displayed on screen, clearly displaying the critical features of the component. If the features are saved associated with the predefined view, these are also imported and accessible through the user views, further improving the visualization of design specifications. If the product manufacturing information is directly linked to the model faces, then features can be quickly extracted from the model, and the information can be quickly applied for faster and more cost-effective production.
Okay, as you can see that this model information that we add in can be used downstream, which is a really, really nice tool because it saves us a lot of time as we work downstream. What about inspection? This can be also used in inspection. So a product called Power Inspect by Autodesk CAM, and you find that that information will feed back to be inspected to make sure it's correctly done. Now here you see a probe that's busy probing across as we go along. And again, looking at the inspection side of it and how it would all tie in. So what will happen here essentially is that the model information will be available inside of the CAM environment and inspection environment, and as you inspect, you make sure and reference to see what is out of date and what is still in line. Again, with the tolerancing as well. So moving on to the takeaways from the exercise, we find that the changing industrial revolution, the 4.0, as we recap on this, we see that the way we're designing is becoming a lot more different, a lot more advanced, and information that we work with is used downstream, which saves us a lot of time, and the information is, of course, true as we move along. And then also the standards that we work with. So we've seen that when we're doing the setup on the Inventor side of it, the annotation automation. So basically, doing your annotation inside a 3D model can be automated and brought across into the drawing environment. And finally, we looked at design to manufacture. So when you do the design, when you take it into the CAM environment for manufacturing, how that information is translated and moved across. Next, we're going to look at some questions. So if you have any questions, you could put them in the type box. If not, you could always get in touch with me at daniel@bakerbaines.com. It's my email address, or you can always give us a ring at the office and we can have a discussion about it. So I'll give you a couple of minutes to actually put in any questions if you have any on the type box. Thank you. Okay, so no questions. All right, okay, thank you very much for attending. If there's anything that you want to recap on, please feel free to give me a shout or pop me an email. My name is Daniel, DANEL, @bakerbaines.com, and I'll be glad to help you out or assist you or give you more information on this topic that we discussed. The presentation and the webinar will be available to you afterward. So if you want to go over it again, you can always go over it. Thank you very much, and I hope to see you again on the next, or hear from you again on the next webinar. Thank you very, very much for attending. Have a good day, everyone.